Okay, hello everyone. So in the last video, I went over how to do a sign diagram for the velocity function. I went over the VT and the AT, the differentiation process behind that. We found some initial conditions of a little particle or something in motion. Again, they'll probably just, change up what the actual object is, but the same sort of underlying concept applies. You could do it for cars. You could essentially do it for anything that, has a frictionless surface. All those kind of conditions that they tell you to exclude in differential calculus courses, because they just want you to focus on the calculus and not all these possible variables that are associated with it. And again, we found initial conditions, and we sort of started getting an idea about what it actually means for a positive and negative velocity, and what it actually means for the velocity function in terms of how it relates to the displacement function to find when an object is turning around. Okay, so we're going to expand off that knowledge that we learnt in our first video to be able to work on the next question. And the next question asks us, and in case you didn't actually pick up because I didn't explicitly write it, but the object turns around. Oh, this whiteboard marker works well. The object turns around at t equals 2 and t equals 6 seconds. So it changes direction at those times. Again, see part 1 if you want to actually know what I'm talking about and get some context here. But from that, what we have next is the question that I sort of addressed a few times over this, but when is the velocity increasing? And again, we can use our sign diagram to be able to get this, but we're going to need a sign diagram for acceleration. Okay, you're probably wondering, well, why do we need a sign diagram of acceleration to find out if velocity is increasing? That's a good question. Well, think about it this way. Acceleration is a v prime of t. So it's the first derivative of acceleration. And what do derivatives tell us? They tell us whether a slope is increasing or decreasing. So the acceleration function will be really good because it's telling us, if we draw a sign diagram of it, the intervals for which velocity is increasing and the intervals for which velocity is decreasing, which again can come in handy quite a bit because it's important to know when an object has positive and negative velocity. And again, you've got to think about what velocity means in a physics context as well, because a negative velocity could just mean that it's moving in a different direction to have a negative velocity. Or it could mean that, that's essentially the main time you'd have a negative velocity, when you're moving in the direction opposite to the positive direction of that vector quantity. So in our case, when we think about it, it's actually moving to the left. And of course, a negative acceleration could mean, again, that's slowing down as well. So we can get an idea of what's happening to these functions by just considering, well, what does a positive velocity mean? What does a positive acceleration mean? And generally, I've sort of covered what most of them mean in a bit of context here, but they all sort of link together and it works really nicely. But enough of me jibber-jabbing away, because I've done a lot of that over these videos. Hopefully some of it's sinking in. But to get our actual acceleration function and find out what's happening to the function when it equals 0, we actually need to, of course, solve for t, because t will give us that value on the acceleration diagram. Okay, so 2t, equals negative 8 equals 0. And again, we set it to 0 because we want to find the stationary points of our vt function, our velocity function, because the stationary points of our velocity function will essentially show the splitting point in between two intervals, an interval when velocity is increasing and an interval in which velocity is decreasing. So, 2t equals 8. Okay, how did I get that? Well, it's negative 8 on the left-hand side, so it needs to be positive 8 on the right-hand side, because we inverse the operations. And now, a little bit more magic. Oops, if I can write properly. T equals 4. And again, all I've done there is I've just moved it from the numerator on the left-hand side into the denominator on the right-hand side. And 8 divided by 2, bit of simple arithmetic there, we get 4. So whoop-de-doo-dah, we've found our stationary point of the VT function, and this, again, when you think about it, think back to curve properties. When we take the derivative and we find when the derivative equals 0, which is what we've just done, we're finding again the stationary point for the previous or original function. Okay, cool. So we know that this is going to be 4. But what happens before? Is it going to be a negative velocity here, or is it going to be a positive velocity here? What's happening to the slope of that velocity function? I'm not going to keep you in suspense for too much longer because the answer is really just a few calculations away. Sign diagrams are really easy to put together when you know what numbers you've got to put in. And again, you just look at it to the left of the stationary point and to the right of the stationary point. Here we had 2 stationary points to survey. Now we've only got 1 to survey. So again, we just pick a value to the left, pick a value to the right. We can make it any value. We could make it, you know, something less than 4 here, maybe 1, maybe 2, maybe 3. Or then something greater than 4, so maybe 6, maybe a million, I don't know. Generally you want to keep it so your arithmetic is, you know, reasonably straightforward, so I wouldn't pick any, you know, big numbers like 727,637, because, you know, it's freaking pointless. Okay, so now what we do is we simply substitute those values into the acceleration formula. So the A of 3 equals, let's see, 2 lots of 3, take 8, which equals 6, take 8, which equals -2. And we don't really care about the 2 there, we just care about that negative sign, because the sign diagram is all about the sign that's out the front, the sign that tells us whether something is positive or negative there. And now what we do is we find the A of, let's say 5, so it's just a matter of, you know, recalculating it. And 2 times 5 is going to make 10, take 8 is going to make 2 in the end. And so from that we know that that's positive there. And let's think back to our original context. What was the original question they were asking us? Well, they were asking us if velocity was increasing. So if velocity is increasing, that means that the derivative, and the derivative of velocity is acceleration, the derivative must be positive for velocity to be increasing. Think about it as in terms of a slope. Velocity is increasing there, the derivative is going to be positive, isn't it? Make these connections. The more you make the connections, the easier it will be, the more it will make sense, and you'll find quite a few intrinsic links that really work to your advantage in motion. So, velocity is increasing when t is greater than 4. Okay, so we've got an idea of when velocity is increasing. That's great, because now we can move on to another complex question, and that asks us, when is the speed increasing? And this one's, you know, it's a bit more difficult. Speed is a scalar quantity. However, I'm going to give you a few rules that will really help you out here. And I'll sort of explain them a bit from a motion perspective, so get your physics hat on just for a minute or so, because helps if you understand why. But if the signs of AT and VT, so our velocity and acceleration function, if they're opposite, then speed is decreasing. Okay, think about it this way. We have positive velocity, so you know it's moving to the right, and it has a negative acceleration. It's going to be slowing down because the acceleration force is going to cause it to go positive velocity, because it's moving in that direction, you know, it's moving forward, but the acceleration is causing it to slow down. And that means that the speed is decreasing, because the object's slowing down. And you know, speed is whether you're slowing down or you're speeding up. And now what happens if they're the same? Well, speed is increasing. Okay, let's think about it this way. You know, we're travelling in the right direction, to the right, so we have a positive velocity, and acceleration is positive, so that means that we're getting faster, because of course, for every, say, if you're going 8 meters per second, and you've got acceleration of 2 meters per second, you're getting 2 meters per second, or should I say 2 meters per second squared, sorry, but you're getting 2 meters per second faster every second. That's where meters per second comes from. So let me just do it with a line here, and this should be pretty fun because I get to go pretty fast. Start off a reasonable pace, but then we shoot up like that. That's what's happening. So again, when they're positive, speed is increasing. Sorry, when they're the same, speed is increasing. Because you can have, velocity moving in the negative direction, and you'd have the same thing happening in the negative direction if acceleration was the same sign. Okay, so remember those two rules. Maybe write them down somewhere. Remember them and make sense of them. Hopefully I've explained them. I could go into more depth, but, YouTube does have time limits, and I have other maths to do.